We're now looking at reacting mass calculations. We're looking at the first question. Now the first question, and how I like to lay these out, is I always have to start with the equation. So for this one we've got 2 aluminium oxides going to 4 aluminiums and 3 lots of oxygen. Then what I like to do is on the side I write mass, MR and moles. Then I read the question, and our question says calculate the mass of aluminium. So the first thing I do is I go to where my mass is, but underneath aluminium, and I'm going to put an equal sign because that is where I'm heading to. Calculate the mass of aluminium that can be formed from 1020 grams of aluminium oxide. So what I'm going to now do is I'm going to calculate my MR of aluminium oxide. So for this I've got 2 lots of my aluminium, which has a relative atomic mass of 27, plus 3 lots of my oxygen that has a relative atomic mass of 16. And when I type that all into a calculator, I get my MR for aluminium oxide is 102. What I then do is I need to calculate my moles for my aluminium oxide. I have my mass and I have my MR, and I want to calculate the moles. So here I'm going to do mass divided by the MR. So I'm going to do 1020 divided by 102, and that will give me my moles. And when I do that, I get 10 moles, or MOL. Now what I need to do is I need to look at my big numbers, my molar ratio. So here, I've got 2 lots of this makes 4 lots of this. So that is a 2:4 ratio. Now I can simplify that ratio to a 1:2. Now I've got 10 moles on this side. How many moles of aluminium I need to do? Well, this is 10 lots. So I need, and then this needs to be 10 more lots. So if I do 2 times 10, I would get 20. Or I can take what this is and times by 2, and that gives me 20 moles. So that is how many moles of aluminium I have now. My MR is just of Al, there's only one of them, so that is 1 times 27, or just 27. I times these 2 numbers together, and that will get me my grams. So here I'm going to do 27 times by 20, and that gives me 540 grams of aluminium.